the new topic. We will just continue with the last lecture because it was my mistake and I'm sorry. I didn't know that we need to know about this topic also. Okay? About the connections of cerebellum and which in other words known as cerebellar pathways. Okay? Cerebellar pathways, when we spoke about the white matter in the previous lecture, we said that we have three main peduncles in the cerebellum, superior, middle, and inferior. And those peduncles usually contain the myelinated fibers that enter or leave the cerebellum. Yes? The ones that enter, we refer to them as afferent tracts, okay, or bundles, and the ones leave the cerebellum are efferent. And the efferent tracts usually arise from the intracerebellar nuclei. Don't eat gray seafood, yes? Dentate, emboliform, globose, fastigium. We said that the dentate, emboliform, and globose leave through which peduncle? The superior, while the fastigial one through the inferior. Okay. So it's the same thing we're speaking about, but a little bit in more details. So when we speak about these pathways, or about the myelinated axons, the bundles, or the tracts enter or leave the cerebellum, okay, we have to know that we have 8 afferent pathways and 4 efferent pathways. Okay? So when we speak about these pathways, في عندي 8 bundles حزم من النيورونز عمالة تدخل على السيربيلم, and there are 4 bundles that are leaving the cerebellum. Okay? Grouped together. When we speak about the 8, 8 بأربعة, remember this. When we speak about the 8 ones, okay, afferent ones, so to classify them, 3 بيجوا من وين؟ من السيريبرال كورتكس. اوكي؟ 8 بيدخلوا على السيربيلم. 3 حزم or 3 tracts من السيريبرم. 3 من وين برضه من تحت؟ من السباينال كورد. اوكي؟ بضل عندي 2، واحدة من الفيستيبيولار نيوكلياي تاعت البالانس. اوكي؟ هذول بيدخلوا على السيربيلم بيروحوا على الفلوكيولو نوديولار لوب. اللي حكيت لكم عنه المرة الماضية اركي سيربيلم. اوكي؟ related to balance. Vestibular nuclei, where are they located?
Lower pons.
At the junction, or they span the junction of medulla and pons. Okay? So those, or this tract, vestibular cerebellum, most probably it will end the cerebellum through the medulla. Inferior cerebellar peduncle. Okay? And the last tract, اللي هي الثاني, comes from the midbrain usually. Tictocerebellar tract, which comes from the tictum and red nucleus. Okay? Sometimes they call it tictorubral cerebellar tract. Okay? Rubral means red nucleus. Okay? So that's the last tract. So it comes from tictum and red nucleus in the midbrain and enters the cerebellum through superior cerebellar peduncle. Okay? Superior cerebellar peduncle. And I will tell you now in these details. فعندي 8. اوكي 3 من البرين اللي بيجوا من البرين اللي هم واحده بينزلوا من السيريبرال كورتكس على البونز بيعملوا ساينابس في البونتين نيوكلياي وين بيروحوا؟ to the opposite side. They become transverse pontine fibers which will become the middle cerebellar peduncle. هذا هو الميجر afferent pathway by the way في السيربيلم. يعني اذا كنتوا تجمعوا الافرنت pathways 50 ل 60% من الافرنت فايبرز عددهم بيجوا من هذا الباثوي لحاله، وال 40% الباقيات اللي هم السبعه تراكتس من ناحيه عدد حجم. So when we speak about number of neurons, so we have cortico-pontocerebellar pathway, okay, هذول من السيريبرم، والثاني بينزل على الانفيريور اوليفري نيوكليوس من السيريبرال كورتكس، بورتو اوليفوري شو بصير؟ سيريبيلار باثوي. بدل ما يروح مباشره للسيريبرم بينزل على الميدالا على الانفيريور اوليفري نيوكليوس. من الانفيريور اوليفري نيوكليوس بيروح وبيدخل عبر الايش؟ عبر الانفيريور سيربيلار بدانكل. فهذا هو الاونلي باثوي الافيرنت فايبرز فيه بتكون ايش؟ كلايمبينج فايبرز. كلهم ال8 باثويز هذول 7 منهم معظم كلهم ماسي فايبرز except this pathway cortico olivo cerebellar pathway from the cerebral cortex to the inferior olivary nucleus to the cerebellum. اوكي؟ هذا هم الكلايمبينج فايبرز. والاخير بيروح للريتيكولار فورميشن سيريبرو ريتيكولو سيربيلار باثوي. اوكي؟ من الريتيكولار فورميشن. 3 من السباينال كورد، واحد نسميه anterior spinal posterior spinal وكيونيو سباينال كيونيو سيربيلار. اوكي؟ الكيونيو من الكيونيات النيوكليوس. الماضيه في شيء اسمه باليو سيربيلم الشاحب. You remember the paleo cerebellum? Okay. شو الفانكشن حكينا mainly posture and crude movements. Okay. وين موجود حكينا؟ في الميديال بارت of anterior and middle lobe. Anterior and below it the middle lobe. Okay. فالآن اللي هو اسمه الثاني كان spinal cerebellum لأنه الكوميونيكيشن بيكون بينه وبين إيش؟ spinal cord. So the spinal cerebellum, which is made up of the medial part of anterior and middle lobe. فلما بيجوا هذول الافيرنت فايبرز يدخلوا، جزء منهم لازم يروح للانتيريور لوب من الاعلى، وجزء بيروح للايش؟ للميدل او بوستيريور لوب من الاسفل. فالبوستيريور سباينال والكيونيو سباينال تراكس بيدخلوا من الاسفل عن طريق الانفيريور سيربيلا. الانتيريور سباينال بده يدخل على وين؟ بيروح للانتيريور لوب، فما بيدخل من الاسفل، بيطلع بيعمل تحويل يوتيرن وبيدخل عن طريق السوبيريور سيربيلا. اوكي؟ للانتيريور لوب، لانه الانتيريور لوب بالاعلى. فايه الافيرنس؟ واحد من الثمانيه بدخل عن طريق الميدل سيربيلر بيدانكل اللي هي بيورلي اللي هو الميجر افيرنت باثوي اللي هو سميناه ايش؟ كورتيكو بونتين سيربيلر باثوي. اثنين عن طريق السوبيريور، تو سمول تراكس، فيري سمول تراكس سباينال، اوكي؟ اللي هم الانتيريور سباينال والتيكتورال سباينال سيربيلر تراكس، اوكي؟ تيكتو سيربيلر تراكس. فاثنين بيدخلوا عن طريق السوبيريور والخمس الباقيات عن طريق الانفيريور. اوكي؟ الافيرنت باثويز الان الافيرنت باثويز اربعه. اوكي؟ اللي هم those which the bundles which will leave the cerebellum. Those four will leave the cerebellum through the four nuclei that don't eat grassy food. Okay? Those would be either leaving through the superior cerebellar peduncle or through the inferior cerebellar peduncle. تتذكروا الميدل completely purely 100% afferent fibers اللي هم cortico-ponto cerebellar pathway. بس. Okay? So they will be either through the superior or through the inferior cerebellar peduncle. Through the superior, dentate, emboliform, and the globose will send their neurons. Okay? So the two pathways you will see they are called globose, emboliform, lateral pathway, because they go to the red nucleus in midbrain, and the other one is dentothalamic, from dentate nucleus to the thalamus. The two efferent pathways. فطلعوا التو efferent pathways من وين طالعات؟ من الايش؟ من اللاترال فري intracerebellar nuclei. The last one اللي هي ايش؟ fastigial nucleus will send its tracts through the inferior cerebellar peduncle. Fastigial vestibular pathway وين بيروح؟ to the vestibular nuclei. cranial nerve number 8. والثاني vestigial reticular to the reticular formation. Okay? Also within the middle of the bronchial. فالinferior cerebellar peduncle بيحتوي برضه efferent fibers اللي هم ايش هذولا؟ من الفاستيجيال nucleus. Okay? So to summarize this, when we speak about the cerebellar peduncles, we have superior, middle, and inferior. In a matter of size or number of neurons. لما بحكي عن السوبيريور سيربيلر بيدانكل، السوبيريور سيربيلر بيدانكل almost or mostly اوكي ايش بيكونوا الفايبرز؟ افيرنت. اوكي؟ بس بضل في حوالي 10% منها اللي هم الافيرنت القادمات، two small tracts. Those are the anterior spinal cerebellar and the tectocerebellar pathways. اوكي؟ 10% afferent. فهي 90% 90% شو بتكون؟ efferent tracts اللي هم ثنتين. شو هم؟ هسه حكيناهم. dentothalamic، globose، emboliform، وين بيروحوا؟ lateral pathway. اوكي؟ 90% هذول بشكلهم من النيورونز دير in the superior peduncle. 10% will be what? afferent. Anterior spinal and tectocerebellar tectocerebellar nucleus. فأنتوا لما بتسألوا عن السوبيريور بيدانكل mostly efferent leaving fibers. لما سألتوا عن الميدل purely completely afferent fibers اللي هو which tract 100% afferent اللي هم which tract cortico-ponto cerebellar pathway أو cortico-pontine tract. Okay? And lastly, the inferior حكينا الميكست والميلي
75% afferent
75% حتى لو المرة الماضية ايش؟ افهم هذه معك اللي هم الريمينينج ايش؟ الريمينينج 5 باثويز مش هم 8 1 2 3 4 5 اوكي و25% شو هم الافيرنت اللي هم من الفاستيجيال نيوكليوس اوكي اللي هم الفاستيجيال فيتيكولار وفاستيجيال فيزيكولار اوكي so these are the connections or the pathways of the cerebellum. You can take these handouts if you want. Okay. Now, another thing, a student came yesterday or and asked me what's the difference between gustatory and the secondary somatosensory. مين اللي أجاب سألتني امبارح؟ مش موجودة؟ Okay. Just to let her know. Okay. Now she told me about the location. What's the difference between the gustatory area and the secondary somatosensory area? It's a little bit confusing because of different research studies and different findings. Okay. Now, when we speak about the gustatory area in the brain, which is previously known as Brodmann area 43, okay? Gustatory area is the area that related with the function of what? Taste perception, okay? اللي لها علاقة بالتذوق, okay? منطقة التذوق, it used previously to be assigned as Brodmann area 43, اللي هي وين موجودة؟ في lower part of post-central giants, okay? This was the first age research or the previous research studies. Now recently, however, recent studies have assigned that or found that based on new technologies and research, it is actually located in the frontal operculum and in the anterior part of the insula. Okay? It's not Brodmann area 43. So what is the operculum? Operculum is a Latin word that means the cover, الغطاء. ليش سموها الغطاء هاي المنطقة؟ It's the part of the brain that covers the insula. So if you look to the lateral sulcus, this part, which includes high central sulcus, part of the frontal, part of the parietal, part of the temporal, okay? Cerebral cortex, which are actually forming here the lateral sulcus. This is the operculum. In Latin, they call it pars opercularis, the cover. So you have to remove this part of the brain in order to see what? Inside the insula, right? So this is the part which we refer to it as the operculum, okay, or pars opercularis, okay? Pars opercularis or operculum, which in other words the cover in the cerebrum, okay, which covers the insula, is actually divided into 3 parts based on the lobe it's located in. So the part here anterior, not this one, I'm speaking here, so if you reflect it, so if you reflect the operculum, you see in here, if you look carefully here, this is, for example, the central sulcus. Okay? Now we speak about this cortex here, covering this region. You see, this region of the cortex, which is covering. So it is divided into mainly 3 parts. The part here, which is considered part of the frontal lobe, we call it frontal operculum. Behind the central sulcus, superiorly here in the roof, parietal operculum, and all this one here, temporal operculum. Okay? So the operculum is actually 3 parts: frontal, parietal, and temporal. The frontal operculum, recently saying that the frontal operculum and the anterior part of insula is the gustatory area. Okay? So if you look carefully here, if you look to the central sulcus here, okay, so it should be in this region and deep. So here, this is, oh not this one. Should be over here in the deep part. So, what about the secondary somatosensory area? Secondary somatosensory area, they discovered that it is actually the parietal operculum, the roof of the center of the lateral sulcus behind central sulcus. If you look to the central sulcus, this is lateral sulcus. If you look the roof من الداخل, which is here, this is the roof inside, the part inside. You see it? This is the roof. This is the coil. Could be frontal or could be parietal operculum. This here is the insula. This here is what? Temporal. This is the temporal operculum. Okay, part of the temporal lobe. So the parietal operculum is what? is the secondary somatosensory area. Central sulcus. هذا الجزء الفرونتال جزء من ايش؟ من الجاستاتوري recently. Okay, along with the anterior insula. This part behind here should be what? The secondary sensory area. Okay, the secondary sensory area. So if you look into the insula, this is easier for you guys. You look here into this cover. This here, where is the central sulcus? We could say this is the central sulcus. Okay, this roof here is the frontal operculum. Frontal operculum, along with this green part of the insula, all this region here is what? Gustatory area. This part here only. Secondary somatosensory. Okay? Just to avoid confusion. Now, speaking about basal nuclei, inshallah, Dr. Uthman will cover you mostly the pathways and structures. We here will speak only about the gross anatomy of the basal nuclei. Basal nuclei are masses, as you see, of gray matter that is located where? In the basal part of the cerebral hemispheres. That's why they call it the basal nuclei. If you look to the cerebrum, they are mostly in the lower part of the cerebrum. Okay? In the basal part. Okay? There is a previous anatomical classification and there is a functional recently classification for these nuclei. Anatomical one based on what? On the structure, because they see them close to each other, okay, or connected. But the functional one is the real one, or the true one, because it's the one related with the pathways and the connections, okay? In the old traditional classification, basal nuclei included four: the claustrum, amygdala, and the corpus striatum, الجسم المخطط, which is further subdivided into caudate and lentiform nucleus. Okay, caudate and lentiform. Now, this is the traditional one. They found that when we speak about basal nuclei function, what is the function of basal nuclei?
Movement coordination.
Motor coordination, mainly inhibitory. They inhibit, okay, the contraction of antagonist muscles. So if you wanna do, this is in the simplest manner also, I'm speaking. Okay, so if you wanna do, like, for example, flexion, okay, they will have coordination with the cerebral cortex. Okay, not directly. They don't have a direct descending pathway. They influence the cerebral cortex. Okay, so that they will tell the cerebral cortex, okay, to promote the contraction of the flexors, and it will inhibit the cerebral cortex, which related to the contraction of extensors. Okay, for example, so you can do this movement of flexion of your hand, okay, or of your digits. Okay. So flexion, the same here, biceps, triceps. If you want to do flexion for the forearm, they could enhance their contraction here, but their main function to inhibit contraction of the triceps. By this, very easily you can do the flexion. If there is no basal nuclei, the contraction will be what? Very rigid, because this muscle will not relax. Okay? So will be something we call rigidity in movement. Okay? That's the main or the simplest way of how these basal nuclei function. So they are basically four. In the traditional one, they call the corpus striatum, which is the main part, basal nuclei. Okay. Then there is the amygdala and the claustrum. Those two, they found not to be related to what? To basal nuclei actually. So they removed them. Okay. They are no longer part or functionally part of what? Of the basal nuclei. Amygdala is a Greek word which means what? Almond. Close. Because when you look to it, it's located in the lower part here, at the end of the caudate nucleus of the corpus striatum. I will speak about it. But when you look to it, this is the amygdala. Amygdala is recently found to be functionally related to what?
Limbic system.
To the limbic system. Okay? Emotions, behavior, whatever. Okay? So it's no longer part of the basal nuclei. It's located in the temporal lobe and part of the limbic system. Claustrum is this shield or line here, the gray matter, if you see it, okay, clearly. It's a line of gray matter. I'm not sure if you can see this line here. Okay. This line, okay, which is a band of gray matter between what? Between the corpus and corpus striatum and the insula. You look carefully to this transverse section of the brain. This is here the insula, okay, covered by the lateral sulcus. This is the corpus striatum of the main part, the basal nuclei. In between there is what? a band, a thin band of the gray matter. Okay, here and all the way here. This band of the gray matter, which we refer to it as the claustrum. Okay, claustrum is separated. Okay, first from the corpus striatum of basal nuclei, okay, by which we call it external capsule of white matter. Okay, and it's separated from the insula by which we call it the extreme capsule. So from the insula by the extreme capsule, and from the corpus striatum by external capsule. Okay, its function recently until now unknown. Okay, the functional classification now. Functional classification, they found that actually basal nuclei will include the corpus striatum member, the subthalamic nuclei. Okay, those are two small nuclei located below the thalamus. Okay, and the substantia nigra, the black substance. Where is substantia nigra? In the midbrain. Okay. I forget to bring you an image for the subthalamic nuclei. Sorry. Subthalamic nuclei, small nuclei of gray matter beneath the thalamus. They are located in the diencephalon. Just below them, connected close to them, you get into midbrain. Okay, so they are closely connected to the upper part of what? Of substantia nigra. Okay, just below them. There is the substantia nigra. I told you substantia nigra located in the cerebral peduncle of what? Of the midbrain. See? It's the region of the gray matter. Why it's nigra? Why it's black? Melanin pigmentation. What's the type of neurotransmitters there? Dopamine, dopaminergic neurons. Those dopamine neurons are very important because they are the inhibitory neurons. Okay? Dopaminergic inhibitory neurons. It makes one unit that is involved in the regulation of motor function. What about the corpus striatum? Corpus striatum اللي هو من اسمه striated body, الجسم المخطط. Okay? Corpus striatum, when they looked to it, they found that it's made up of two parts actually. This is here most anteriorly, the head that I'm speaking about. If you look, there is two parts of gray matter and they are connected by what? By lines. You see these striated lines? That's why they call it corpus striatum. Okay? Corpus striatum is made up of two parts. This one and this one. Okay? This one here, which actually resembles this part in a lateral view, which we call it the caudate nucleus. Okay? Caudate. Like the tail. Caudate, like the caudate lobe on the liver. It means the tail, okay? Because it resembles the tail. Okay? The other one, they call it the lentiform nucleus, which is here. Okay? You see it here. Lentiform nucleus, which is here. If you go more, you will see that this will start to enlarge and this go up and reduce. Okay? So, this lentiform, Latin word, that means shaped like lentil. What's lentil? Haptilatus. Okay. So, lentiform, limited haptilatus. So, two nuclei together, connected with each other, they will form the corpus luteum, the corpus striatum. Okay? The corpus striatum, now there will be some gray matter. Okay, some nerve bodies here passing in between along this area. So when you look to them here, you will see these striations. Okay, that's why they call it corpus luteum. It's made up of two main nuclei, the caudate and the lentiform. Okay. Now, when they further look at this structure, they found that the lentiform itself. Okay. So this is it. When you look deeper to it, here should be the lentiform, and this is the caudate. Okay? The tail of the caudate is usually associated with the amygdala. Okay? But it has nothing related in function. Okay? When you cut the lentiform and look deeper to it, you will see that it's made up of two parts actually. An outer dark part and inner paler part. شاحب أكثر. Okay? So they refer to these two structures as the putamen and the globus pallidus. Okay? The putamen and the globus pallidus. So when you look to the lentiform, which is lentil shape, it's located deep. This is the lentiform here. Okay? It's located deep in the white matter of the cerebral hemisphere, and they found that it's made up of two areas of gray matter, distinguished by color. The outer one, which is very dark in color, they call it the putamen. Okay? It's like the shield, derra. Okay? That's what does putamen mean, the shield. Okay? The deeper one, which is more or less round and paler in color, شاحبة أكثر. They call it the globus pallidus. Globus means globe, rounded shape. Pallidus pale. Why it's pale? ليش شاحبة؟ مش that gray matter. Because of high concentration of myelinated axons passing through it. Okay? So there is a high concentration of myelinated neurons passing there. عشان هيك لما بتطلعوا عليها بتكون لونها ايش؟ مش غامق كثير مثل الايش؟ البوتامين. Okay? تحتوي myelinated nerve axons. So we have a putamen and we have the globus pallidus. Globus pallidus further divided into a lateral and medial part. Okay? Clear till now? Now, so in this classification, we have corpus striatum بيتكون من كوديت الذيل ومن اللينتيفورم. اللينتيفورم من برا لجوا subdivided into putamen and globus pallidus. Okay? Now there is a new term used now. When they found that the caudate, if you look carefully, you will find that the caudate is associated directly with the putamen of the lentiform nucleus. Okay? So they recently referred to that, to the caudate and to the putamen, this part, as you see it, together as the new striatum. Okay? New striatum. Okay? And they are actually functionally related. How? By that, this part, the new striatum, اللي هم الكوديت and putamen, فصلوا بينهم خطوا new striatum. Those are representing the input receiving part of the basal nuclei. الانبوت بدخل عليهم، بيوصلهم النيرف signals. Then they will send their signals to the globus. الجلوبus هو الايش؟ The one that gonna send the output, okay, to the other areas, okay, of the brain. Okay, so here is the input in the new striatum. This one is the output. Okay, the globus. That's why they refer to those. You look at caudate and putamen as new striatum. Globus pallidus still as it is. Caudate, حكيت لكم, it's tail, large C-shaped mass of gray matter. As you see here, it's located, of course, lateral to the thalamus. هم كلهم lateral to the thalamus, okay? And they are separated from the thalamus by what?
Internal.
By the internal capsule, okay? I should have a better image. In this transverse image, you could see them, okay? Those, the lentiform hydrodate hole, شايفينها? And this one here is the thalamus, okay? So this white matter passing here is the one which we refer to it as the internal capsule. Internal capsule, white matter, is made up of two limbs. Anterior limb and posterior limb. In the anterior limb here, it will separate what? The caudate from lentiform. اللينتيفورم جزئين، putamen الغامقة هذه والشاحبة globus pallidus. Okay? The globus pallidus. The one. So anterior limb separates the lentiform from the caudate. Now if you go at a higher level, at a transverse, you will see that some gray matter start to connect between those two. Here. Okay? بتصيروا تشوفوا اللي فرجتكم اياه شوي في الكورونا here. This thing here. And that's why they call it corpus striatum. Okay? You will see that some gray matter passing in the anterior limb of the internal capsule to connect the caudate with the lentiform. Now the posterior limb of the internal capsule will separate شو هاي سميناها؟ lentiform nucleus. Will separate the lentiform from the thalamus. Okay? So by this, في عندي 3 areas of white matter there. Okay? عندي internal capsule with 2 limbs. It separates the lentiform from caudate and thalamus. بعدين في عندي external capsule. The external capsule separates what? The lentiform or the corpus striatum in general from the claustrum. And then we have the extreme capsule, which separates the claustrum from the insula outside. So 3 parts of white matter separating those nuclei or gray matter areas. Okay? Extreme, external, internal. Okay? حكيناهم review. Corpus striatum, okay, is made up of 2 nuclei, okay, caudate, putamen, and globus pallidus. Those two together are lentiform. Okay? Lentiform nucleus is those two. What is the new striatum حكيت لكم؟ البوتيمين لحالها of lentiform along with the caudate. ليش هذول سموهم جزء واحد new striatum? They are functionally related because they are received the input. Okay? And what are the basal nuclei again?
Substantia nigra.
Substantia nigra. Subthalamic nuclei. Corpus striatum. Corpus striatum منقسم لإيش؟ lentiform وcaudate. Lentiform putamen Okay? Functionally speaking, حكيت لكم هو control muscles of the contralateral side of your body. Right and left and left and right. Okay? By indirect pathway. كيف يعني indirect? It influences the cerebral cortex. Okay? It doesn't have, they don't have basal nuclei a direct descending pathway. Okay? They just influence the cerebral cortex. الانبوت بدخل وين؟ النيو ستريتم. شو هو النيو ستريتم؟ بوتيت وين؟ بوتيمين. اوكي؟ والاوتبوت من وين؟ اوكي؟ شو هي اللينتيفورم؟
Lobus pallidus
بوتيمين and the globus pallidus. So what's happening there? When you have a need to take up your coffee cup, okay? What you're gonna need? You need the contraction of, as I told you, the flexors, okay, in the forearm to flex the digits, and you need the contraction here of the biceps and brachioradialis, okay? So these contractions which you need to do, okay, the cerebral cortex now, okay, will send first input where? To the new striatum, okay? Caudate وإيش وبوتيمين. Those will analyze this requirement signals and they will send their analysis where?
Lobus
To
pallidus.
the globus. Globus will give the order to the premotor cortex, okay, in the brain, okay, telling it what? To contract the flexors and to inhibit the contraction of the extensors. Okay? Now this signals, now once it reaches to the premotor area or to the precentral gyrus, okay, of the brain, it will go back all the way through cortico-spinal tract, okay, to the lower motor neurons in the spinal cord, and from there to these muscles, okay, telling them to contract the flexors and inhibit the contraction of the extensors. Now, if there is something damaged here in the basal nuclei, this message will not be applied to where? To the cerebral cortex. So there will be difficulty in what? In this kind of movement. Okay? Why? Because there is difficulty in inhibiting the extensors. Okay? That's what does it mean in simplest pathway. Clinically speaking, damage to basal nuclei, okay, can lead to two different kinds of disorders. Okay? One of them will lead to hyperkinetic disorder, the other one is hypokinetic. Okay? The hyperkinetic one, which we refer to it as Huntington disease or chorea. Okay? And the other one, Parkinson's disease. What's the difference between those two? So, chorea is a Greek word that means dancing. Okay? رقص. ليش? Because there will be an exhibition hyperkinetic. Because it's شغال لوحده. Involuntary contractions. Okay? Of the limbs. Okay? So, exhibition of involuntary, quick, jerky, irregular movements that are not repetitive. Okay? They are not repetitive. Okay? And it's a very important sign of which we refer to it as the Huntington's disease. The cause there, degeneration, damage, okay, to neurons where? In the striatonigral inhibitory pathways. Okay? So there is a communication pathway between substantia nigra and new striatum, caudate and putamen. Okay? This communication, if it's lost, okay, so there is no more signals. This actually is an inhibitory pathway. هم شو بيعملوا هذول؟ substantia nigra, okay, بتودي signals بتروح للنيو ستريتم. النيو ستريتم بيودي هاي السيجنالز لوين؟ للجلوبس. الجلوبس بوديها للسريبرال كورتكس وبتصير الكونتراكشن. الآن another signals will go back into caudate and putamen. Okay, للنيو. These signals will enhance those two to inhibit the substantia nigra. خلاص بكفي. We did our movement. Don't do inhibition. Don't release dopamine anymore. Okay? Don't release it. Okay? We did our function. Whatever, however, if this not happened, okay? If it hasn't happened here, as you see, this pathway has been degenerated due to deaf neurons here in the caudate and in the putamen. Okay? There will be an overacting substantia nigra. Okay? This overacting substantia nigra will continuously release what? Dopamine. This dopamine will be going where? Into the striatum. The globus pallidus. Globus pallidus continuously will be what? Sending
Cortex.
to the inhibitory signals to the cerebral cortex. Okay? For certain things. This will stimulate the cerebral cortex now. Okay? By this stimulation, will continue what? Producing these involuntary movements. Okay? The opposite side, the hypokinetic Parkinson's. شو بصير في الباركنسونز؟ الدمج بيكون وين؟ السبستانشال. Not in the others. Okay? So in this part, we have an inhibition instead of overaction. But no signals going into the globus and into the cerebral cortex. Okay? So there is no inhibition, okay, of these contractions, contralateral contractions. Okay? Since we don't have inhibition of contralateral contractions, it will be very difficult to what, as I told you, to move your hand. If you do flexion, there is no inhibition to the contralateral ones. Okay? So it will be very difficult. Also, because there is no inhibition anymore, you will see that during relaxation, as the patient is sitting down or relaxed, there will be what? Continuous contraction. Tremor. Okay? But this tremor is just a relaxing or resting tremor. It's not the tremor that you see where in the cerebellum, in the case of ataxia. That's a purposeful. That's when you want to do something, you will start doing this tremor. But this tremor is just during this resting tremor. When you ask you to do something, so you are resting, can you stand up, please? You will see that he has difficulty in standing up. Okay? Hypokinetic movement. Okay? The tremor disappears. But there will be what now? Rigidity. Because these muscles are refusing to relax. Okay? Based on this. So there will be a degeneration of neurons in the substantia nigra. This will lead to reduction in what? In dopamine. And that the receptors in the striatal neurons will not receive what? Enough dopamine to send inhibitory signals. Okay? To the cerebral cortex. Parkinson is distinguished by three distinct features. Resting tremor, as I told you, rigidity, and bradykinesis, which means hypokinesis, okay, or what? Slow movement, okay? So the patient will walk slowly, and if you ask him quickly to stop, he cannot, okay? He may be fell down. And, yeah, people are fine. Good luck.